Hello, we're going to share some games today. I'm Tony Bearden, and Caroline, who started Bubbly Maths, who does wonderful maths shows all over the world, and I work a lot together to make the learning of mathematics enjoyable for young people and help everybody to appreciate mathematics. And today, Elizabeth from the AIMSEC team is joining us, and we're going to play some games. So our program today is called the 15 Games Collection because all these games are related. And through playing these games, your learners will improve their knowledge, understanding and skills of place value and number sense, working systematically, looking for patterns and counting all possible outcomes. They'll be thinking about symmetry and about making connections between different mathematical ideas, even doing some simple coding. Now, we feature the learning spiral because we believe that learning goes on all one's life, from the cradle to the grave, and the spiral here is for the school years, when young people start school, 5 or 6 years old, and then go on through the learning process, which takes them up layer by layer, higher and higher on this spiral, until they reach the upper secondary level on the school leaving year, when they're launching into life and they have got all these skills, knowledge and skills from school that will help them thrive in the big world of the adult world. Now, we always start with something very simple that young children can share with everybody else and enjoy, something mathematical and simple. And this time it's noughts and crosses, which is a very well-known game, otherwise in America called tic-tac-toe. And then we're going to discuss a little what are the reasons for learning through play. We're going to play the spin high, spin low game. Then we're going to play some target games. We've got a big collection of target games. We're just going to play a couple. And then the 15 game, followed by looking for patterns in Jura's Magic Square. And we're now reaching upper primary, but all of these games are very suitable for secondary as well. And then the next level is making your own magic square. We're going to be looking at playing indeed an online game. We've got different versions of that uses words, and we've got a different version which uses different words, but here we call it the online game. And then the jam game, which is also called Siege. We're going to compare different games because by the time we're reaching the upper secondary level, we should look back on all these games and see what the similarities and what the differences are. And that will I promise you, prove very interesting. And then we're going to do some coding, writing computer programs, programming software. And everybody will be able to engage with that, even if they've never done any coding before. And they'll be able to see how this could lead on to writing simple codes for computers. And finally, we're going to reflect again together on why does play matter? Why is it important? Why is it a good thing?
We want you to just be part of it, not just sit and watch us. And that way you'll get more benefit out of the workshops. So we're just encouraging you to be as involved as much as possible, and so that it means more for everyone.
We're going to play Noughts and Crosses. It's a game that many of you will have played before, perhaps even all of you. Do you know the strategies then? Do you know how to win? Um, do you know a little bit more about this game? What else do you know? Here, Caroline and Elizabeth are going to play. You both see that you can refer to the squares on the noughts and crosses. You can refer to them like B2 is the middle one and C3 is the top right one. Caroline has got the little board showing, and whoever's playing all through the afternoon, Caroline's going to be writing it down. So, Elizabeth, would you like to say whether you want to be a nought or a cross, and where you want to put your first mark?
Yes, could I be a cross? And can I put my first mark on B2?
Caroline, it's your turn.
Right. Well, I would like C3, please.
Okay. Could I be C3?
C3. Well, don't have much choice. I've got to go with A1.
Can I be C1?
Are you sure? Thank you very much. That's very kind
Oh,
of you.
that shows you how good I am at games. It's going to be quite a day.
Okay, now
Can we
then,
do it again?
so what we would like to suggest now is that you can play this game in with a whole class and divide the class, all the learners into two groups, and you can get one spokesperson for each group if you like, or of course in class you can have them the learners playing in pairs. What we're going to do is to make it a sort of whole group activity here so everybody can participate. So Caroline's going to erase it. She's got a laminated sheet there, and then we're going to play again with Caroline's team this time and Elizabeth's team. So will you all decide which team you're going to be on? Are you going to be on Caroline's team or are you going to be on Elizabeth's team? And we'll let Caroline, well, we won't ask you, well, maybe we will. Where should Caroline start? If you've decided to be on Caroline's team, you should advise her. But
Come on, teachers, I need help. Oh dear. Don't leave me to my own devices. Okay. Oh, I've got, yep.
Now,
the first suggestion was A3, Elizabeth.
Thank you, Mary. Thank you for that.
so if you put nought or X before your suggestions so that I know. Cynthia suggested C1. I think I'm just going to go with that.
It's Elizabeth's turn now.
B1. Thank you, Mary.
A suggestion for Caroline. Elizabeth?
I think even I can see this time where I have to put it. Yes, I agree with you, Mary. B3.
But I'm going to go with B3. I think this is a stalemate.
Looks like it. Yep.
Okay, it's Elizabeth's turn.
Okay, we'll just put it in C2.
I think you can see that nobody can win now. You've been too clever, both of you, both teams, and well done, everybody. Okay, so we've played that game, and now we're going to go on and talk about play power.
Play is, it says there, is crucial for development in communication skills, in young people's communication skills, or it's crucial for just learning to think. When you start school, it tends to be based on play. That tends to be quite typical, although it hasn't always been that way. That you literally are laying down a solid foundation for, as it says there, literacy and numeracy. So you've got vocabulary development, you've got critical thinking, you've got communication between the learners. They work things out for themselves. It's extraordinary watching two young people literally devising their own way of doing something, and then exercising imagination through storytelling, which they can be pretty wild stories, but that's the exercise in their imagination is a huge step towards them having great visualization skills when they're doing mathematics. So play nurtures development and fulfills the baby's inborn need to learn. Now we are born with a need to learn. A baby has to learn in order to be able to walk, in order to be able to talk. And just they learn from all the little things just by putting things in their mouth, by making sounds, by observing their older siblings or other family playing peekaboo and hiding and things. And so a child can play on their own, and they can play with other young children, or can play with an adult. When it's adult, it can be more led, but it also needs to be completely free play. That depends which you tends to work if you start with free play and then start guiding when you see what they're doing and asking questions. And it encourages adults to communicate with the children. So you can encourage the parents of the children that you teach to communicate with the children about what you're learning here, use the key questions, give those to your parents so that they can guide their children. And then also absolutely when not to do anything, when to just observe or let the child just get on with discovering for themselves, and when to either guide or intervene for safety reasons.
Yes, I took these ideas about play from the Literacy Trust. But I added the pictures, and so sometimes it's very much free play, as you see with the children in the water. It looks like a hot day in the garden. But sometimes it's guided play with a purpose, like the cooking. Those boys look as if they're going to be making something yummy to eat, and they seem to be enjoying it. But they will regard that as play too.
Yes, I mean, continuing to talk about play, play gives young people the chance to be spontaneous. You may think your child should be rolling the truck on the ground or doing a calculation in the way you do it, but that doesn't mean that the truck is not equally useful as a stacking toy, or the calculation won't work out in the child's own way. And I think this is actually very important, that you don't try and interfere with the young people when they're playing, because if you try and impose on them the way you think, you could be inhibiting their learning, because they'll have their own way of working things out and their own way of doing things. Play gives children choice and enables them to make decisions for themselves. Having sufficient access to play outdoors in open spaces and near trees, and having activities to choose from, will allow children to express themselves. I mean, I remember myself as a child, and I'm not so sure that children do it enough these days, but we spent a lot of time outdoors playing. It developed your social skills because there was no adults around. You had to learn to play together, and you had to learn to be fair. You did all sorts of things. You made dens, you swung on a swing from trees. It wasn't always safe, but it taught you a lot of skills that otherwise you wouldn't have learned. And you don't want adults interfering, because it's your chance to become an independent little person when your parents aren't there. And you can actually work out if you're one of the main leaders in the pack, or if you're more of a support worker. You know, you kind of work out things about yourself when you're playing. So yeah, play is very important, and it's important not to kind of get too involved. And in fact, when children ask you to play, this is like point number 7, play gives parents and teachers the chance to learn how to play again. It's actually quite sad how you find that you've forgotten how to play, and that you feel actually quite kind of insecure and vulnerable once again, because you've actually forgotten how to play. So you have to just watch the children around you and try and become a child again, and just enjoy what's going on, and not be trying to take control or guide them to learn a particular thing, just allowing them to learn things in their own time and in their own way. So play has got a very important part to play.
One really important factor about play is to learn how to be a good loser. It's emotional intelligence. It's learning, like, for example, if you're running a race and you didn't win the race, then that can give you the incentive to train harder. If you're not the top in your maths class or your whatever other class, it can do two things. It can give you the incentive to work harder, to learn more, or it can get you to give up. Now, we all know people that have given up, which is really, really sad. And then it's our job to help motivate them to want to start again. But one of those things, a huge factor of that is learning how to be a good loser. And that doesn't mean that you love to lose. It means that losing doesn't make you give up. Losing gives you determination and also pride in the person that, let's say if you're in a race, pride in the person that did do best. Another aspect is you can learn from that person, think, oh, what did they do that I didn't do? How can I become better by modeling them? What factors can I add into my life, my actions, my sports, my maths, that I can learn from them, and even go up to them and say, can you teach me how to do this? All of those things. And just as it says there, learning to play well, both by themselves and with others, sets children up to be contented and sociable. Because that lonely child is the one that might be the bad loser that just feels like a failure.
Something that worries me is that babies are natural learners, and they go to school usually unless something not so good has been happening to them. Preschool, they go to school eager to learn, as learning is a natural thing. Babies fall over literally hundreds of times while they're trying to stand up and become steady on their feet and learning to walk. And they don't give up. But what is really sad is that often before they've been in school very long, children don't see learning any longer as being, oh, this is great, I'm learning something new, and seeing it as being for their own benefit. If I can get up and walk like those grown-ups, then the world is there's so much more I can do. If I can learn a lot at school, there's so much more I can do. But they don't think like that because somehow school has squashed all that natural learning instinct in the children. And so I think as parents and as older people and as teachers, we do need to bear that in mind. Now, this is a game that we're going to play, and you can easily make a spinner like that. Caroline's going to demonstrate it in a minute. And this is a very adaptable game. The principle is the same, but you can play this with just tens and units, or you can play it with hundreds, tens and units, or you can play it, as we're going to do, with 4 little boxes there. And each time Caroline spins the little paper clip there, a number will come up, and then everybody needs to decide where to put the number in one of those boxes so that they're going to get the highest possible number. Now, what we thought we'd do here is I would play with Caroline. So Caroline's got 2 sets of boxes there, and she's going to put my numbers in one of them and her numbers in the other. Those numbers are going to come up when she spins the spinner. So Caroline, would you like to start? It looks as if it's on the line, Caroline.
No, it's not. I can see it's on 7. The tip is on 7.
So where are you going to put your 7, Caroline?
Me. We want the highest number that we can. So shall I put it on 1s, 10s, 100s, or 1000s?
So there's a lot of
Oh,
probability.
7,000. Okay. Oh, that's a good way of putting it. Okay, that's it. I'm going to go with Cynthia. 7,000.
Right, spin it for me then, Caroline.
Oh, 7.
Well, I'm going to decide on this, and I'm going to put it in for 700. Now, this is taking a chance, and it's a question of, do I think that an 8 or 9 are likely to come up? Well, let's see. So, Caroline, spin again for your team.
0. Where shall we put it, team? Highest number we can possibly make.
Should you put it in the tens, the hundreds, or the
Okay, 0. Jonathan says 0. Okay. Tony,
right?
it is yours.
I think he means to put it in the units, so that's
That's what, yeah, I think you meant make it 0.
okay.
Yeah.
So would you like to spin for me?
And so does Cynthia. Yep, you've got a 3.
Ooh. Well, my team, who'd like to advise me where to put the
Cynthia
3?
said units.
You could put it in the units, yeah. Good
Right.
chance you might get higher than that for either the tens or the.
Okay, let's
Cynthia
put it in the
says
units
10s.
then. Oh, somebody else has said tens. I think let's put it in the tens.
Ooh. Maximum
What's-
number we can make is 7,900 and something. Okay. And we've got a 6.
She's only got the hundreds or the tens boxes left.
Is it going to be worth 60 or 600?
6 tens.
Ooh,
Spin for me.
Tony, I'm getting nervous now. Oh, that's a 2. Well, actually, no, at the very end, it's between the 2. So I will spin that again. Oh, I wish I'd kept it with the other one. You've got a 7 now.
Oh, a 7. Okay. Well, I think it should go in the thousands then, because we've only got one more to come.
So we need an 8 and a 9, an 8 or a 9. Okay, everybody root for 8 or 9, at least if you're on my team. And if you're not, still root for an 8 or a 9.
Oh, you lucky
And we got a 9.
person.
Oh,
and
no,
it
you
doesn't
haven't done your
matter.
units now. I think it's very, very important that you to get your units.
Okay, it doesn't matter though what I
You've
get.
got
You
a
won.
6. Yeah.
Okay, now everybody should be able to see that this involves quite a lot of decision making, and you have to be thinking about which numbers, oh well, all the numbers can come up anytime when we spin, and which will benefit you, which will mean you'll get a higher score, which will mean you'll get a lower score, and which box you should put your number in when it comes up. So there's a lot of luck here, and there's quite a lot of skill, and it's going to help children to develop number sense, but and understand place value. But it's also going to help them to think about probability, because they want to win, and they'll be thinking about, not for any formal way, but thinking about which numbers are more likely to come up, and whether that'll be a benefit or whether it'll be mean you lose. That's just one game. Now we're going to go on to a different game. Here we've got 2 more points from our Literacy Trust. One is it enables, when children are playing, it enables parents and teachers to observe and understand the sort of something about the feelings that the child is experiencing through the body language in particular. And you'll know when you should incorporate yourself in the children's play, make a suggestion, or actually get more involved in that. And so that's one aspect. Another is it teaches the parents and the teachers patience and understanding. I mean, many parents play with their children. I think there's probably less family board games and card games than there used to be because everybody's playing on screens now. But it does help parents and teachers to make play fun for their children and to help their children to become better and by practicing even when they don't want to practice, that it's worthwhile if they're going to get good at a sport, for example. Getting up in the morning to go for those swimming practice or whatever it is. So it teaches parents intelligence and patience and understanding and thinking about the purpose of any particular play, how this might help the child in some way or other. So the next game we're going to play, and Caroline's got the grids ready, is Target 100, and there's another similar game, almost identical, except this time it's adding up 3-digit numbers and it's got 3 of them, whereas the Target 100 is much simpler. I'm going to play against Elizabeth and then we'll play much more slowly. So Elizabeth and I will play, and here it's not like the previous game where we want to make the biggest possible total. We're going to fill in 4 numbers and we want to make the total as near to 100 as possible. So would you like to start, Elizabeth? When you've got your 2 numbers.
4.
A 4. Well, I think I'll put a 4 in the units column.
0, Tony.
I'm going to put that in the units column.
That's another question you can ask your learners is, does it matter whether it goes on top or on the bottom when you're adding? Tony's got 0 in the units. Elizabeth's got 4 in the units. Next one. 2 for Elizabeth.
Okay. 2, I think I'll put in the tens.
My one?
That's a 0, Tony.
Oh, goodness me. I'll put that in the units.
That's a 2, Elizabeth.
Okay, we'll put that in the units.
0, Tony.
Oh, Caroline, you're fixing it. You're teasing me.
I wish I was that clever that I'd be able to fix it. I wish I was that clever that I'd be able to fix it. Elizabeth, there's only one other place for it to go. So that.
Okay, well, Elizabeth adds up to 66. Mine's going to be less than that unless you go to 7, 8 or 9.
I'm really sorry, Tony. It's a 1. I'm sorry. I'm so sorry. So Tony's got 10. And Elizabeth got 66.
That was entirely luck or bad luck for me.
Bad luck.
We're going to play again. So would you like to spin for Elizabeth again, Caroline?
Do you think we should start spinning for you this time, Tony? Give you better luck?
Oh, okay, you can if you like. Spin for me.
Oh, 2.
2. Well, I'm going to make a decision to put it in the units because it's basically we want something around 40 or 50, ideally, I think. But anyway, if we're going to put it in the tens, but we'll see. Decide what's best for Elizabeth, if you like.
A 9. This is a good number to have. So
Should she put the 9 in the tens or the units is the question. Tens. Mary says 10.
Mary, thank you, Mary. I'll take your advice. So we'll put the 9 in the tens.
I have had the situation before where I got 2 9s and I ended up going to nearly 200. So that was interesting. Tony, 7.
Aha.
So now looking back, if Tony had put the 2s there and then 7, she'd be just about spot on 100. That's the beauty about this game. A small number is not necessarily a bad thing, but it depends what other numbers you get.
Yeah.
7 and 10s.
Okay. Right. Elizabeth now?
8.
Well, I certainly don't want to be putting it in the tens, so let's put it in the units.
My turn.
That's what Cynthia said as well.
We're in agreement, Cynthia.
That's 7.
Well, we'll go much too high if I have a 70 something for the other number, so it has to be the units. Okay, Elizabeth, a spin for Elizabeth. Please make a suggestion.
That's an 8.
Oh, well, we just have to put it in the units, don't we?
This is as bad as getting all zeros or getting all high numbers.
Yes, Mary's suggesting we put it in the ones column, the units
Oh,
column.
okay, thank you, Mary. Spin. 9, Tony. I'm sorry.
Oh my goodness. Oh, well, now I could still be the winner because
You could,
depends what's going to come up next.
if I get a 9, then kaput, or an 8, possibly.
And it's a 6.
A 6, okay.
If we were playing this with children, we could now stop. We could now get them to do the adding up.
Of course.
We
yeah.
could ask them to, to use a show board to show the answer, so we'd know that everybody could do that addition. If we were working with primary school children, we would want them to be now thinking about the this whole process of what's a good strategy for this game? How are we going to try and win the game? They need to be thinking of the mental arithmetic, whatever number they put in the tens, how are we going to get that to add to another number that's in the tens, that's going to be the 2, whatever the units are, the 2 are going to be adding up to something that's close to 100. So if one's more than 5, the other one's got to be less than 5.
I've got a question, Tony. The
Yes?
great question is, seeing those 2 results, who do they think is going to win, and what answer do they estimate without actually doing the calculation? Who do they think has got the higher number, and what do they think that higher number might be?
Without doing any calculation.
Sorry, it's not the higher number we're looking
It's
for.
the lower
now
number
either.
you want.
It's the number closest to 100.
But there's not very much difference in it, is there?
Yeah,
There's 3, Tony. There's a whole 3 points. That's a lot.
Yeah.
1 point would have been enough.
And you know what? I'm thinking maybe your spinner's a bit biased, Caroline.
We're going to play 2 more games, and I'm just showing you that these are the cards that we're going to give you PDFs that you can print out and cut the cards out to use. One's going to be the 15 and the other's going to be the Annenline game, and we're going to play those games. Now, this one is called the 15 game, and I'm going to play it with Elizabeth. And in fact, we call this whole cluster of games the 15 games collection. So we're going to take it in turn to choose one of the numbers 1 to 9, and then it's going to become my number or Elizabeth's number. And the object is that one of us is trying to collect 3 numbers that add up to 3, not 2, not 4, but 3 numbers that add up to 15. In this case, it's a bit like noughts and crosses. You can fill all 9 boxes. We can take all 9 numbers, but of those, it's 3 that add up to 15 that will be a winner. So what we want you to do before we start playing is to write down all the winning combinations, which will be 3 numbers that add up to 15. So can you find some more triples that add up to 15 and just write them? 1 plus 9 plus 5 add up to 15. Now there are more combinations of 3 numbers that add up to 15. Just write them down. However, all the ones you can find that add up to 15. We'll just give you a minute or 2 to do that. We've got 1 plus 8 plus 6, 2 plus 9 plus 4, 8 plus 4 plus 3, 7 plus 6 plus 2. It's one of those situations where if you start to think systematically, you can pull out all that you need. So I'm going to show you the rest. There they are. 1 plus 8 plus 6, 2 plus 9 plus 4, 2 plus 8 plus 5, 2 plus 7 plus 6, 3 plus 8 plus 4, 3 plus 7 plus 5, and 4 plus 6 plus 5. Okay, 8 different combinations. So let's play the game, and I'm going to choose 5. Elizabeth, what would you like to choose?
I think I'll choose 4.
Okay, I'm going to choose 7.
I think I shall choose 8.
So I have to choose 3.
You've won.
Oh my goodness, Tony has, yes.
Well, you see,
But can I get a draw? Can I get a draw?
no, I've won already. You might have drawn.
But then you just went first. Nobody said you could go first.
Well, now we'll play
That's a good
again.
point. I think
Now
English
we'll
never
play
goes
again,
wrong.
Elizabeth.
We should have
You
tossed
can
a
go
coin to see
first.
who went first.
No, actually, whoever goes first, the other person can draw a wheat or maybe even beat them. So you can go first, Elizabeth.
But what if I get beat again? Okay, I shall choose 5.
Right. I shall choose 9.
I shall choose 6.
I shall choose 2.
And I shall choose I shall choose 4.
That's it. No choice. No more choices, Tony.
Oh, I can choose more numbers.
No, you can't.
No, because I've won, Tony.
Oh, you have one. Oh my goodness.
You don't get your third shot because I've got the answer first.
That just shows I wasn't thinking clearly. Okay, so this is a great game and the children will love it, and they will be learning these combinations of 3 numbers that add up to 15. They'll be thinking strategically. They'll be they're sharpening their mathematical thinking. So we do really recommend the 15 game, and you can play it with the whole class in 2 teams. Or once the children know, and you get large cards so that they can all see the cards as you're giving them to one team or the other team. Or you can play it, get the children to play it in pairs, and and record how often one person wins and how often the other person wins, best out of 5 rounds, let's say. Okay, so we're going to move on to, we call these activities Command the Robot, and this is learning computer programming or computer coding in a playful way. It's quite serious learning, but it's something that even preschool children are able to learn. Now, we've got 3 very simple commands here that are going to be used. One is to going forward, and the number that follows is the number of steps. So forward 5 tells you to take 5 steps forward. Right 90, it's a right or left turn, so children are going to learn the difference between their right and their left. And it's going to be turning 90, which is a quarter turn. So it's keeping it simple. Later on, we can change the angle, but for the time being, when we start learning this turtle graphics or logo language, we're going to restrict it to turning from a right angle. And just those 3 commands, we're going to do some drawing. And the way we suggest that you might do this with your class of any age group is to get them out in the open air so they've got plenty of space, and they're all going to be robots, and you as a teacher are going to give the commands and they are going to follow exactly what you tell them to do. So you're going to give them one command, they'll do it, then another command, they'll do that, and see if they can follow your commands. And then once they've got the hang of it and practiced a bit, somebody from the class, one of the learners, can be the person who gives the commands, and you as the teacher can join in and be one of the robots. And then as they get better at this, you can add more commands, but we're going to start with just 3 of them and you'll get the idea. I did say a minute ago, and I think maybe some of you wouldn't have, wouldn't have believed me that preschool children can learn to do this. So some very well financed nurseries have got what is called a little robot. This one is called Roma, but they come in various different shapes and sizes, but they've all got a pad of numbers on the back, and they have got a little, you can, by touching the pad, you can key in, as you do on your computer keyboard, you can key in the instructions. And children are actually doing this sort of thing now on an iPad or a tablet, playing this sort of game. Or better still, they've got an actual little toy on the ground that will move forward and turn to the right and turn to the left, and the children can press the keys, and they can actually press not just one command at a time, but they can press the keys to make the robot do, let's say, 6 commands, one after the other, and to go around the legs of a chair and come back to them, or to go to the door and come back, or they can have a mat on the floor, which is a little town, and the Roma can go round the town following these instructions. So making a game of it, and the small children are actually doing serious computer coding. This game, this language rather, was written way back in the 70s with little toys like this Roma to teach children to do computer programming, but that teaches them to think mathematically, and it's still very popular, and as a good way to start learning to do coding. So we recommend you, there's these 2 links there to the this language of the Logo language, and we'll also give you links later on where you can actually download the software for free, and it's very easy to use. So if you want to do it with your classes, it's a good way to introduce programming. And Caroline made a video yesterday which she's going to show you of doing just this.
I'd just like to make the observation that we happen to have squares on the floor. This is not necessary. It just helped us. This is at the Maths Museum in the north of England. This just happened to help us with the video, but you do not need the squares on the floor.
We have the wonderful GTEN at Math City Leeds, and he's going to be our robot, and I am going to command the robot. GTEN, forward 2, right 90, forward 4, right 90, forward 2, right 90, forward 4, right 90, aha, ended up where he started, excellent. Now, see what happens with this one. Forward 4. right 90, forward 4, right 90, forward 4, right 90, forward 4, right 90. Okay, so we had a 2x4 rectangle, now we have a 4x4 square. Now we're going to see what happens if we do some zigzagging. Forward 1, right 90, forward 2, right, no, left 90, forward 2, right 90, forward 2, left 90, forward 1, left 90, forward 1, left 90, forward 2, right 90, forward 2, left 90, forward 2, right 90, forward 1, right 90, and he's back where he started. Thank you very much, GTEN.
Okay, well, beautiful. So that illustrated very well, just carrying out the instructions that you saw on my slide, the pattern that you saw on my slide. I'll put that pattern up again later, and if you remember it, you'll be able to link the two. The next video is a really funny video, and it's about a dad, and he says he'll make a peanut butter and jelly sandwich for his kids if they give him precise instructions. And why we're showing you this is we think it's a really good way for actually making a game where the children are going to learn something, but what they're going to learn is using language precisely, because it's tremendously important throughout the whole of maths, not just for coding. It's very important that you say precisely what you mean, and there's no ambiguity about it, because that's the nature of mathematical language. And we're very tolerant as teachers in giving children the benefit of the doubt when they write something down, or when they say something about, it's mathematics. But actually, it can't be right unless it's grammatically correct, unless it's absolutely accurate. And that's what this father is trying to make a game to help the children to realise the importance of being absolutely precise about what you say, which you need to be if you're going to write a computer program.
You know what, I'm hungry. I could really go for a peanut butter and jelly sandwich. Do you guys think you can write down some instructions and teach me how to make a peanut butter and jelly sandwich?
Yeah. I'm done.
Step 1. Get 2 pieces of bread out. Got him. Get a butter knife and get some PB. Take 1 piece of bread, spread it around with the butter knife.
No, Dad, with the peanut butter.
I'm just doing what it says. It says take 1 piece of bread, spread it around with the butter knife.
Hold on.
Get some jelly, rub it on the other half of the bread.
No, Dad, open the jelly.
Well, it doesn't say to do that. Put the breads together on top of each other. Take a big bite. This doesn't taste like a peanut butter jelly sandwich. Fail.
Yeah. Oh, yeah. Sorry, I had to make it extremely specific.
Oh, good. I'm starving. Take 2 pieces of white bread out of the bag. Take the lid off the jar of peanut butter. Get a butter knife and stick it inside of the peanut butter jar. With the knife, scoop a bit of peanut butter out
A bit, that means like a lot.
A bit means a lot?
In my world.
All right. There we go.
Doing better than before, though.
Open the jelly jar. Squeeze it onto the other piece of bread.
No.
Done. Closer. Get 2 pieces bread. Get some peanut butter. Take the peanut butter knife. Open the peanut butter. Put the knife in the PB. Get some jelly. Open the jelly.
No.
Squirt the jelly onto the bread.
You're supposed to.
Take the butter knife with the peanut butter on it. Wipe it all over the piece of bread that's blank. Take the butter knife. Rub the jelly all over the piece of bread.
Oh, he's doing better.
It says all over. Put the 2 pieces on top of each other.
This is how I meant.
Take 2 pieces of white bread out of the bag. Take the lid off the jar of peanut butter. Get a butter knife and stick it inside of the peanut butter jar. With the knife, scoop some of the peanut butter out of the inside of the jar. Spread your scoop of peanut butter onto one of your pieces of bread with a knife.
No.
Squeeze some jelly onto the other piece of bread. Spread the jelly on the bread with the butter knife. Put your 2 pieces of bread, peanut butter and jelly sides together. Done. Get 2 pieces of bread. Get some peanut butter. Get some jelly. Open the peanut butter. Get a butter knife. Put the butter knife in the peanut butter. Take the butter knife out of the peanut butter.
You did it wrong. No.
Take 1 piece of bread and take the butter knife that has the peanut butter on it and spread it all over the top of the piece of bread.
Dad,
That's the top.
I mean the sides.
Squirt some on another piece of bread. Take the butter knife, rub it all over the top of the piece of bread.
I quit. You're not making any sense. Zari ruined it on purpose. He knows how to make one. I know, Evan. It's the joke. It's the game that we're playing. Oh.
Do you know how to eat a piece of bread? You want to take your sandwich with you?
I edited a bit.
Take 2 pieces of white bread. Take the lid off the jar of peanut butter. Get a butter knife and stick it inside the peanut butter jar. With the knife, scoop some of the peanut butter out of the inside of the jar. Spread your scoop of peanut butter onto the face of one of your pieces of bread with the knife. Squeeze some jelly onto the other piece of bread. Spread the jelly on the bread with the butter knife. Put your 2 pieces of bread, peanut butter and jelly sides together. Done.
Now eat it.
Not the best,
Well, you made it.
but
so.
I think it qualifies. That's a win.
Okay. I think the reason was fairly obvious why we played that video. It was all so people would get the idea that using language precisely is very important in mathematics. And there we go. There's a link if you want to show it yourselves. Okay, so the next thing is we're going to play the An Online game, and this one you can see it's a matter now of collecting 3 cards so that they all contain this, all the instances of the same letter. So we've got different sets of cards that are winning sets here, but for example, and we've shown them in the little sketch, line, an, and on are 3 words that all have an N in them so that they make a set. Also, we could have matched line with laugh and lot because they've all got L's in them. I'm going to play it with Caroline. So, Caroline, what would you like to start with? Caroline has chosen line. I would like to choose lot. what are you going to choose next, Caroline?
You've got an O there. I've got to stop you from getting O's.
Okay. I'm going to choose eat.
You weren't supposed to notice that, Tony. Well, I've got to have it. Well, Tony has one.
So I so what can I choose now? I think maybe I'm trying to think. I'm thinking hard. I'm going to have if.
Yeah, that's a wise choice.
I think so.
Let's see what you're up to.
Just stopping you from winning, actually, Caroline.
Yeah, you're not about to get anything right now, are you? Wonder if we're going to have a stalemate.
I don't think either of us can win. You see, if I choose laugh, Caroline's got line, which would have made that upset. That set.
Oh no, you chose laugh.
Oh, I should have
I
chosen
won.
Anne, and you've won because you've got 3 N's. Oh my goodness.
N.
You've got Anne, on, and line. It's the very combination that we featured.
And online.
It shows you. I'm no good. Okay, so we're going to carry on because we
always learning,
Yeah.
Tony.
Yeah, so Caroline, would you like to tell us about this picture?
This is made during the Renaissance period, I believe in Italy, and if you have a careful look at the features in it, it's an artist. You can clearly see it's a very good artist. There's an angel there, but if you look at the details, you'll see there's a geometric shape there that's made up with a triangle and some pentagons. There's a ladder going up the wall. There's a set of scales on the wall. Well, there's a sphere on the floor. And then you've also got a exam timer and a bell, which could be related to time. But underneath the bell, you have a 4x4 grid that is a magic square.
I'm sorry, but I'm not sure, but I was also going to say that Dürer was German, although he did travel around Europe quite a lot. Dürer was the artist there. And the name of the painting is Melancholia, and I think there's a lot of thought going on, rather serious thought. I think the angel and the little cherub here look quite grumpy, actually.
Yeah, they look more grumpy than sad, don't they?
Yes, so that's Melancholia. This is made very clear, the actual 4x4 magic square.
We're looking for sets of 4 numbers with the same total. So can you see different sets of 4 numbers with the same total?
All the rows and the columns and the diagonals are the same total.
Okay, and what is that total? So what Tony said was the rows, the columns, and the diagonals have the same total. And Cynthia's saying they all add up to 34. Is there any other patterns that anyone can see that add up to the same total? Why do you think the corners, as in the corners of the square? Yep, that also gives us 34, the corners of the 4x4 square. What about these shapes that are on the diagram? Is there anything you can say about them and the totals at their vertices? The diagonal, yeah, so we've got 16 and 6 and 11 and 1, giving us 34. Yep, so the vertices of the diagonal or rhombus giving us 34. Is there any we've not spotted? I think we might have got them. Tony, what were you going to say a moment ago?
I was just going to say the green lines are there. They're just two rhombuses, and so 10, 13, 7 and 4 all add up to 34 again. You might like to look at the four numbers in a corner, like 16, 3, 10 and 5.
Oh, yes. So
So
it's like a 2 by 2 square.
this is so clever, isn't it? What it really shows us is that as well as being an artist, a talented artist, Dürer was also, well, he was pretty good with number, okay, let's just say that. And in his day, a lot of scholarly people were artists. They were also mathematicians, astronomers, scientists. They were, what's the term is polymath. They knew a huge amount of all the things that there were to know. And Leonardo da Vinci is another example of an artist. And he's very well known for his painting, but actually he was an engineer who he did a lot of investigations about the human body and biology, and he also did quite a lot of experiments in sort of engineering and played around with ideas of flying and how you might invent a flying machine. So to come back to Dürer, he again was one of these many talented artists, and so there's no end to this magic square. Can you see lots more shapes here?
Yeah.
But you see, if you look at 11 and rotate it by 180 degrees about the center, then you make the pattern of 12. Though, of course, it's nothing to do with the numbers at the moment. We've just identified the quadrilaterals where the totals add up to 34. But once you've done that, you've got these lovely shapes that have this symmetry. And in the class, you can use this. There's so many different symmetries that can be observed. It will give everyone in the class a chance to suggest something. And when they suggest a rotational symmetry, then ask them where's the center of rotation and what order is that rotational symmetry, what angle are you turning it through to get the next copy which looks exactly the same. There's many different answers to be given there, and it gives, as I say, it's a lovely little bit of bringing the geometry and the transformation geometry and the number ideas all into one lesson, and getting the children all to discuss what they see in these pictures. Having done the 4x4 magic square, and we gave you the answer that because it's a little bit more difficult to use it as a puzzle to find where to put the numbers. We're now going to do something rather easy, and that is to put these numbers 1 to 9 into the 3x3 array there, so that all the rows and the columns and the diagonals add up to the same total. Now let's do some thinking about this before we start. What's the sum of all the numbers from 1 to 9? What do they add up to? And the way Caroline has, if you look at the little box there with the numbers cards on them, Caroline has arranged them, and that gives you a quick way to add up the numbers 1 to 9. You can just add 1 plus 2 plus 3 plus 4 plus 5 and so on, or you can see from Caroline's arrangement there that the total is 45, because 1 and 9 add up to 10, to an 8 and so on, and so very quickly it's 45. And so what must the total be in each row? You've got 3 rows, they all have the same total. What must the total be in each row? Okay, well, could you put that on the chat? What must the total be in each row? The sum of all those cards, the numbers on the cards, adds up to 45. And so we really want to know what must be the total in each row, so that each row adds up to the same total, and all the rows, all the numbers, anyway, add up to.
I guess it must be, if it's 45 is the total and there's 3 rows, I think we would need to divide 45 by 3 to get the total for each row.
Fine. And so now we need to link that with the 15 game that we were playing earlier, and where we wrote down all the combinations of 3 numbers that added up to 15, and that's what we wrote before. And so now we know we're going to put 1, 9 and 5 in one of the rows, 1, 8 and 6 in another row, 2, 9 and 4 in another row or column or on the diagonal. That's what we have to decide. But basically it's like noughts and crosses. It's 3 in a row and in the array exactly as noughts and crosses, and the combinations of 3 numbers that add up to 15 as in the 15 game. So we've and we would hope that the children will be wanting to solve this puzzle as they want to win when they're playing a game, and so they'll be thinking mathematically in order to win, or to solve the puzzle. And so how many times do these numbers come up? That's a clue. How many times does 5 come up, for instance?
Yeah, I mean, it looks like it comes up the most number of times. There's 1, 2, 3, 4 5s.
Okay, and what about what about the number 4 and all the other even numbers? Are they similar? What about the number 4?
I can only see 3 4s.
And what about the number 8?
8, 3 8s.
And 2?
3 2s.
And 6? 3 6s.
6s. Yeah.
Yes, and then some of the numbers only come up twice.
Like I can see that 9 only comes up twice. What other numbers? 7.
One only comes up twice.
Yeah, 1 and 7. Yeah.
And 3.
And 3.
So what we see is that the odd numbers come up twice. The even numbers come up three times. And, well, except 5, which isn't, although it's an odd number, it's rather special. It comes up 4 times. So this gives us a clue as to how to solve the puzzle and where to put the numbers. And there's a diagram to help you. Now, the numbers at the midpoints of the 4 edges, okay, they only occur in 2 of these triples, only in 2 or lines up and down, 1 up and 1 across, or in each case. Okay, so those odd numbers 1, 3, 7 and 9 need to go at the midpoints of the edges. Now for the corners, they're not just on a horizontal line and a vertical line, those numbers, they're on a diagonal as well. And so those even numbers need to go at the 4 corners. And the number 5, see the little diagram there, that shows you that it must go in the center, because that's the only square of the magic square that has 2 rows and 2 diagonals through it, a row, a column and 2 diagonals through it. So now with all of that, we should be able to put the numbers in the right boxes. So Caroline will demonstrate that.
Okay, so I'm going to put the 5 in the middle, as indicated. I'm going to put an even number where you have the vertical and the horizontal crossing. And I'm not even looking at where I'm putting them. I'm just putting them kind
Well,
of
we can
randomly.
check
Let's
it,
see what
Caroline,
happens.
because your 8 and 2 add up to 10. So with 5, they add up to 15. And the 4 and 6 add up to 10. Now you have to be a little bit more.
Yeah, so that's not going to work because 3 plus 2, that would need to be 10. So it can't go there. Let's see what happens here. 3 and 8, 11. That's not going to work. Oh, that can't work. How about no? Have I missed something here? 9 plus 7, 9 plus 6. No, I've already got 6. No, not as easy as I look. I can't just place them like that, perhaps.
Cynthia suggests that the odd numbers must go in the center.
That the odd numbers go. Odd numbers only occur twice. So that can't be right, but that could be there. Aha. That could be there. That's
The mathematical reasoning behind it. Yes.
9, 10, 11. So that could be 4. Right. My mind turned it around and did it the other way around, and that's fine. 7, and then 6 and 7, 15, and 13, 15. That's it. That's better. If I'd done, so I wonder if I just done it. I still couldn't do it randomly. I started off just putting them on randomly, and that didn't work.
No. The whole point about this is it's not random. There are different ways in which you could arrange it, so you can rotate them. But the odd numbers, apart from 5, 1, 3, 7, and 9, have got to go at the midpoints of the 4 edges, so that across with the 5 they add up to 15, and then the even numbers 2, 4, 6, and 8 go at the corners. And
but
you just
not just anywhere. You have to
but
think about where they
you
go.
have to think about it. But you can try, would it fit this corner? Oh no, that won't work. It must be that corner. And a little bit of reasoning, and you can do that quite quickly. We'll move on now to the jam game, and Caroline is going to show us this game. So here we have yellow dots, which are supposed to be towns. Think about this as a map. The yellow dots are towns, and the lines, which are labelled, are roads, labelled A, B, C, D, E, F, G, H, and I. 8 towns and 9 roads. And now Elizabeth and Caroline are going to play. And what they're going to do is they're going to claim a road and say, that road's mine, you can't use it, it's my road. And Caroline's going to mark it in a colour, so that we all know which roads belong to Elizabeth and which roads belong to Caroline. And then this is a sort of war game in a way, because the objective to win, you want to block a town. So you want to take all the roads going into the same town. So for example, if one of you gets roads B, E and D, you will have blocked the 3 roads that go into the town right at the top of this map. And so that could be one winning strategy, but there are obviously lots of other ways of winning, and it's a sort of little battle between Caroline and Elizabeth now.
There, I'm going to need a lot of help with this.
I'm giving you some help right here.
Okay.
And now that help's disappearing. Help's gone.
But there isn't any numbers on the thing.
Not numbers. How many towns?
So Caroline, you choose. Sorry, Elizabeth.
No, Elizabeth's starting. Yeah.
Elizabeth, you choose a road.
I tell you what. If you don't choose the right one, I won't choose it either.
Elizabeth, it's an obvious road for you to choose because of your name.
Oh, yeah.
Thank you for that big hint, Tony. I'll choose road E.
And how many towns does road E have, Elizabeth?
It looks like it's got 4.
Right, so let's see. I'm going to choose road H. Oh, I've done the wrong color. I've given you my color, but that's okay. You can have my
Caroline
color.
likes orange, and she usually chooses orange for herself.
Thank you so much, Caroline, for letting me use your color.
Oh, you're welcome.
Elizabeth, which road do you want now?
I think I'll go for F.
F. Right, I'm going to go for D.
Elizabeth, which do you want?
I'll go for B. B
B for
for,
Bravo.
yeah.
Oh, I've got no choice. I've got to go for A now. A or lose?
Right, so can you explain, because I'm just choosing colours here. Can you tell me so why are you going to lose? Then I might have a clue what's going on.
You have to have 3 roads through the same town.
Yes.
So B, B, A and F
Yeah.
would.
He's going to stop me from choosing A.
Elizabeth would have won. if she
Would
had been able to
Elizabeth?
do-
That's right. That's right. So now, Caroline, you have a choice now.
I've done mine. I put A. I blocked
Okay, so
A.
now I've got to
Now
look
it's
and see what
Elizabeth.
you can do. So you've chosen D, you've chosen, so if you were to choose, oh, Cynthia says Caroline's already won.
Have
'Cause
I?
she's got yeah, you have, because you've got H, no, she's only got 2 roads.
No,
Cynthia.
that's because D's one road. That's this one.
D's the one road, so I
D
think
is
I need
just
to
one
choose,
road.
I need to choose C.
You do.
Are you sure? Oh, Tony, are you sure
No,
you
no,
want to choose
no,
C, Elizabeth?
Yes, I'm definitely going with C, Caroline.
You've got advice from the chat line to choose that.
Oh, okay, that's fair
And
enough
from
then.
Tony.
And I'm going to. I don't think it matters which I choose now. I've got G. Your turn, Elizabeth.
Well, there's only one left, isn't
There's
there?
only one left.
Yeah.
And it was another stalemate.
See, in this game, it's a little bit. It takes people a little bit more time to learn to play the game because they have to see this just as in real road system. Roads go through a town and they've got the same number when they come out of the town as they had when they went into the town. So it's very much like a map, but it does take a little bit of time to learn. But it's actually learning a few more different ways of thinking to the other games, because you've got to sort of visualize where these lines cross each other and imagine 3 lines through the same.
I mean, I was just using symmetry, but I don't know if that was. So because Caroline chose say, H, then I thought, well, I'll choose F, and because she chose B, I thought, well, I'll choose D. That was the way I was, but I'm sure that's not the.
No, there's all sorts of winning strategies here when you get good at this. So notice there are 8 towns, yellow dots, and 9 rows. And the towns all have 3 roads through them. And roads have 2, 3, or 4 towns on them. Now that should be ringing some bells. You should be comparing this with the magic square and indeed noughts and crosses. And the players must claim one of the roads, and to win a player must capture all 3 roads through one of the towns. And you've seen the game played. So what similarities do you notice between the jam game, the noughts and crosses game, the 15 game, the An online game, and the 3x3 magic square?
I've got my fingers held up.
Yeah, there's 5 different games and puzzles, and the similarities, and well,
it's 3 of everything, isn't it?
there's the things that we're trying to collect to get a win are 3 of your mark in a row on noughts and crosses, 3 numbers that add up to 15 in the 15 game, 3 cards with the same letter on, 3 roads through the same town. Okay, it's all collecting 3 of something. What else do you notice about the similarities between these 5 games and puzzles?
I noticed that the number that took me a long time to get used to playing this game, by the way. I've played this a few times now, and that fact that the one road goes through some of the towns is it's a bit of a red herring, but play it correctly, it works. But what I noticed is that Road E has 4 towns, and it's the only one that has 4
So road
towns.
E is like number 5. It's the middle. It's the middle one you must put in the middle of noughts and crosses, and the one you must put in the middle of the 3x3 magic square.
So it's the road to choose first, is it?
Yes, E is the. That's why Carolyn and I were telling you to choose the one for your name.
Because it's got the most number of towns.
Yes, yes. And then, so that tells you something. There's the 9 roads and 8 towns. Well, with the noughts and crosses, there's the rows across, the columns down, that's 3 and 3 are 6, and the 2 diagonals make 8. So those lines in noughts and crosses are the same as the lines in the 3x3 magic square. 8 and 9 seem to come up everywhere here, don't they? So there's a lot of similarities.
What we want you to do is look at this chart and see if you can fill in the blanks. What we've got is 15 game. We had to make the number 15 using 3 numbers, but you could select from all 9 numbers until they were gone. Tic-tac-toe, Tony's just described that. We're looking for the 8 and the 9 within the 15 game, where those come in. Magic square, it's the same shape as tic-tac-toe.
So the headings there, we've only got the headings in the table at the moment. Across the top, it's the names of the different games and puzzles, and down the side, the things that correspond to each other in the connections we're going to make. So what we have here is an idea of they're all really the same game. They're the same mathematical structure. The things that change in one are corresponding exactly to the things that you change in another, and the connections between them. Those are the connections. So there's what I like to say is that the 15 game is tic-tac-toe in disguise. And in fact, it's a magic square in disguise. And it's the online game and jam in disguise, so mathematical disguises. But the correct mathematical word to use is isomorphism. And that's a Greek word, iso meaning same, and morph is about change, how things change. So they change in the same way. So what we've got is not 5 different games and puzzles. Really, in truth, we've only got one structure, one mathematical structure there, and each of them seems very different when you first meet it. And there's no reason that you should connect any of them with noughts and crosses, which you may well have learnt as a child, and you may well have met some of these other things for the first time this afternoon. So these connections are not obvious, and so it's really not something, again, that you would expect the children to spot right away, and in fact not in any one session. What you might do is play these games with different year groups, different times.
The more you play them, the more familiar the children will become with them, and they can be intuitive. Like this game, the game with the roads. It's taken me, the first time I played it was September last year. It's now September 2020. It's now December 2021, and for the first time I actually really got it. But at the same time, playing the game again and again, you grow from it. A lot of people manage to get tic-tac-toe quickly, but the other games take a lot more thought. It's not just an X and a naught, but they are fundamentally the same. The more you play them, the more you can grow with your mathematical thinking, getting them used to this and then spotting the connections, and then looking for connections in other areas.
Once you spot those connections, you see, you don't have to do any more work really in mathematics, and the more mathematics you learn and in university and then beyond in applying the mathematics, you very often find that you save yourself time because you've done all this before. You've actually, it looks completely different context, different notations, different language perhaps, but in fact it's the same mathematics. And once you spot it's the same mathematics, it's isomorphic, you're really strong there on the fact that you just have to do a translation between one and the other, and you've already solved the problem, and you just have to put it in the different context. And so now you begin to see from this this table here that in the magic square the objects are numbers, for example. So go down under magic square and across from objects, and you see there it's numbers, the objects. In the 15 game, they're cards, but they've got numbers on them, of course. In tic-tac-toe, the objects are the symbols are 0 and a 0 or an X. In the Anon line, they're cards. This time the cards have got words on them, and in the jam game you're marking the roads. But look, the number of objects is 9 numbers, 9 squares for tic-tac-toe, 9 words for Anon line, 9 towns as in the jam game. And the relationships between the objects that are all, mapped to each other correspond, the connections. But for the 15 game, the numbers have got to add up to 15. For tic-tac-toe, it's got to be 3 noughts or 3 crosses in a row or column or diagonal. For the magic square, the triple of numbers has got to add up to 15. In the Anon line, it's got to be the same letter, and you have to have roads going through one town. Three roads going through one town. So you can see there's an obvious combination now as we look at it, having played on these games and done these puzzles this afternoon, and the number of relations each time. We suggested you wrote down all the combinations of 3 numbers that added up to 15, and what it turned out was that there were 8 of them, and that was very convenient because, well, it was necessary because we wanted them to be 3 rows, 3 columns and 2 diagonals, making 8 sets there for the winning combinations. So that's about this mathematical disguises, and a little bit of an idea of how you can introduce children in school to this in one way, but not all in 1 year group, but just over time, this sort of spiral learning, relating these games to each other and why they're useful in getting across this idea of always, whenever you've got some maths you need to apply, solve a problem, think, have I seen something like this before? Might not be exactly the same. Even when you do this translation, there may be slight differences, but having seen something very similar before usually helps you to do it again. This is a really important diagram, and there's a lot of research being done about playful learning. Finland ranks very highly in international comparisons, and it has for many years, 20, 30 years or more. It's usually very near the top, and some countries are consistently very near the bottom. Now, how can those countries climb in this ranking, get better? I suggest getting away from the idea of the Victorian, the traditional, the old-fashioned style of teaching, where you explain to children what they need to understand, you show them an example, and then you give them some practice examples. That doesn't work anymore because that's not That's not a high level of cognition or thinking. Mathematical thinking is about working things out for yourself, not just trying to remember what the teacher said. And playful learning is the right approach. Doesn't mean games necessarily. It means a lot of practical activities. And so in the middle of this diagram, you see building blocks of playful learning. And all around it, you see all the advantages of playful learning. Now, believe me, Finland concentrates on this idea of playful learning. Children don't start school until they're 7, which is older than most countries. They have a shorter school day, fewer hours in the classroom. They encourage a lot of play, and in the classroom, they adopt all these methods that involve a playful approach to learning. And what is more, they don't start homework at all until the children are quite, a long way through secondary school, so that the children have a lot of time for playing. And parents share this idea. So this playful learning and not just play, but learning through play happens at home as well as at school. And so now some of the things here you see, you get through this approach to learning. You see that you can get children to invent a game like this one, in which case they're being creative. They're creating questions. So we've got creativity and imagination there, and ability to create questions.
One of my favourite sections is grit, which means tenacity, perseverance, determination. When things go wrong, you keep coming back for more. You don't give up until you succeed. What you start with may be completely different to what you end with. Your original thoughts may end up coming out totally differently. That takes grit. To me, that's one of the most important things. And the other one that I like, that really so many I like there, but agency and autonomy. Being independent learners, independent inquirers is absolutely critical. And when we talk to our students, as opposed to learners, you do the show and tell rather than help them think for themselves, they're not developing autonomy at all. In fact, they're not developing grit either, because it's being effectively spoon-fed.
And then another skill for life is social interaction and relations. Being able to cooperate with other people, be a good loser, but also be a good winner. Don't make somebody who you've just beaten feel a failure, but say how well they played or something. If
you can see why it's a very effective system, because they're encouraging individuals to ask questions, to be curious, interested, passionate. They're encouraging social interactions. It's the opposite to many systems where they just want the learner to sit quietly and listen, and then you show them what to do, and then they reproduce what you've done. So this is the absolute opposite to that. This is encouraging. You've gotten the learners at the heart of things here, and you're encouraging discussion. Nothing, you can ask anything that you don't understand. You're encouraging other learners to talk and to have their opinion, not just the teacher. You can just see why it's a much more effective system.
Why does play matter? Our understanding of learning has changed. It's instead of teaching, it's about learning. It's about being child-centered, learner-centered. And the research coming out of Finland and other countries, there are clear relationships between academic achievement, experiences of play, and the development of social self-regulatory skills. That self-regulatory is really important. So play helps people to build the skills they need in life. Who knew? The research is showing that is the case. And it's hard to predict career paths for young people, especially in this day and age. You don't know what's going to be happening in 10 years' time, or the social demands they will face. So again, tenacity and creativity and autonomy and all the rest of it, and the ability to play and create through play is so much more. It opens so many more doors than creating in a very rigid
And they need to be adaptable, don't they, in life? And this idea of being able to learn for yourself, lifelong learning, and they need to engage in problem solving and exercise resilience and flexibility in new conditions, because there are going to be new conditions. Some links here, because you can find from these links the peanut butter and jelly sandwich if you want to watch that video again, and of all these other links from the Aiming High website. There you see a 5x5 magic square with some of the numbers in, and Picture Puzzler is about that. And also, if you would like to be in one of the GTEN WhatsApp groups, then just send an email to Layla, and she'll put you in one of the groups. And we will be sending out to the WhatsApp groups, the GTEN groups, a copy of this PowerPoint in a PDF form, and you'll be able to have these links there.
So the other place you can always look at is the Maths Toys YouTube channel.
You've heard us say the word AIMSEC many times, so there's lots of free lesson resources on the AIMSEC website. You can go on there and download the resources for free. Also, AIMSEC offers professional development courses, etc. So if you're interested in any of those, you can click on these different links.
Thanks for coming to this workshop. Use AIMSEC ideas on the Aiming High, and add comments in our website there, and share what you've learned with other teachers, please, and try to help your learners have the yes I can attitude to maths. Help them to grow in confidence about maths and to love maths.
Thank you very much.
And thanks for having me. And it's been a learning experience for me, and I've thoroughly enjoyed it. So thanks a lot.
Thank you so much.
This is a Global Teacher Empowerment Network video collaborating with AIMSEC and the Aiming High website. Our mission is to benefit children in disadvantaged communities all over the world by empowering the teachers who teach them mathematics.